So that's how you do a discrete probability distribution. Now, we're going to do the graphing part just so that you can kind of describe it. And so that was our B. We'll graph it and describe it. It ended up being the same type of setup. Because if you look at all of your probabilities, I know for a fact for my math to be correct, it can't be a negative, it can't be or greater than 1, right? It's got to be in between 0 and 1. And so I can do the same thing with the 0.1, 0.2, 0.3. It doesn't look like I really need to go up any higher, maybe just 0.3. And all these little data places are going to be right there. This is 0 to 6. So 0, 1, 2, 3, 4, 5, 6, notch, 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 notch. And I'm literally just doing this, 1, 2, 3, so that I can pick out the correct data. Not correct data, I'm sorry. So that I can pick out the correct graph on the homework, okay? Because you could do the top part correct, but if you can't select the correct graph, obviously you're not going to get all of the points. And then, again, rough sketch it by yourself. If you don't understand how to do the bars, that's fine. I know that when x is 0, the probability is 0.051. So that's like to there. It's just a little itty bitty, what's it called? Almost like a square. And then when x is 1, I've got 0.108. So that goes just past the 0.1. 2 is 0.136, so that's also just past the previous one. And then for 3, I got 0.273, so that's going to go to about here. 0.4, I go down to 2. 5, I got 1.5. 6, I'm small again. It does not matter how rough it is on your piece of paper. You should see some kind of pattern. Do you see how it goes up and then it comes back down again? It's not just this. If it was this, it'd be skewed to the left, right? And if we had just this, it would be skewed to the right. But because we have this like taller graph, this taller bar right here in the middle, and then it goes down on both sides, we would say that our graph is approximately symmetrical. And I do truly believe that y'all could pick the graph by inspection, by looking at the homework, looking at the probabilities, finding where x is 1, it's right here, and then looking to see how do they have their bar graph, like where do they say it is right there, and then we would be able to just kind of follow, because I couldn't get my calculator to trace correctly or zoom stat or do anything last night. And that took what, all of 1 minute to draw a graph? Okay. Now we have C, D, E, F, G to this problem. I have to change pages, obviously. I'll keep this face up so I can like keep recalling it if I need to. But we're going to answer these few different problems. So for C, it says find the probability of randomly selecting a player who practiced for 1 or 2 hours. I see the word or, so that should make y'all think of the addition rule, because it is the addition rule. And then if you notice on our discrete probability distribution, this is a distribution of all of the different probabilities. So all I have to do is just locate the ones that they're talking about and add them together. Okay, I don't have to like take the probability of this over the total. I don't have to do anything like that. I see the word or. I think about the fact that if you not studied, if you practice for 1 hour or if you practice for 2, those are mutually exclusive, right? They're not the same. One is 1 hour, one is 2 hours. So because of that, let me switch colors. If I recall the probability, say 1 hour or 2 hours. The rule for the addition, if they were mutually exclusive, was you take the probability of the first event and you add the probability of the second event, right? So 1 hour. What is the probability of 1 hour? Of the chance that I randomly select a player that, sorry, because it's kind of slanted. My numbers aren't exactly right. But yeah, I have 0.108, right? So if I do the probability, I'm going to do this, y'all. P of 1 plus P of 2, just because I legit ran out of room right there. The probability of 1 hour is 0.108. Add that to, what's the probability of 2 hours? 0.136. They're already in probability form, so you don't have to do anything else other than just the addition rule here. And if you add those up, what you get is 0.244. That's your answer. The only way they get tricky here with the discrete probability distributions and it asking you to find the probability of blank is the words like inclusive, between, at most, at least, right? I kind of have an example of pretty much all of those, okay? But everything starts with what we did for that first hour and a half that we were together. Right? Get this down right here. Here's all the probabilities that now I'm working with. Okay, so y'all, if you're okay, for my D, I'm not fixing to write that whole sentence again. Can I just write more than 3 hours? Is that okay? Yeah? Thank you. I love you too. Oh, it's like meh. So much writing. I really do enjoy stats, but teaching a stats class makes me miss algebra. Algebra, straight computation, just boom, 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 just problem after problem. Here's like stories being told. Like, Logan's like, nah. Okay, I'm not writing it. Find the probability of randomly selected player who practiced more than 3 hours.
Does that include 3 hours?
What do you think? More than 3 hours? Question mark. So yeah, no, 3 hours is 3 hours. 3 hours is not more than 3 hours, right? So what I'd be finding, that came out of my mouth all weird. So what I would be finding would be the probability of what? If you look at all of my data, what is more than 3 hours? 4 hours, 5 hours, or 6 hours. So again, I'm going to kind of change, instead of F-O-U-R, I'm just going to write 4. Okay. What I'm finding is the probability of 4 or 5 or 6. And all of those should be implied that they're hours because that's like what we're working with right now, right? So I literally look here, y'all, at my DPD. Okay. So this is going to be P of 4 plus P of 5 plus P of 6. I love it whenever the next section kind of builds on or uses the previous section. Feels like there's less to teach. What is the probability of selecting a player who practiced for 4 hours? 4, just 4. 0.210. I'm going to add to that the probability of a player practicing, so many P words, for 5 hours. 0.153. I want to make sure I'm right. Yeah, it's 5.3. And then I'm going to add to that the probability of selecting a player that practiced for 6 hours. Legit, y'all. Just add those up. You should get 0.431. Because what I'm doing is working with a probability distribution, and everything's already in the terms of probability. Whenever I do the addition rule to answer these A, B, C, D, E, F, G parts, you quite literally just like, that's it, that's your answer. You don't have to do anything else, okay? Okay, so, got 3 more. So many more. E, find the probability of randomly selecting a player who practiced between 1 and 4 hours. Between. Between means that it is strictly greater than or less than. Right? And if we want it, we could probably write that somewhere if we want to. Between is strictly greater than or less than. I just use the symbols. Right? And then just for continuity here, y'all, if you see the word inclusive, the inclusive means include. Those are the two different things. So this inclusive means it can equal. Between means it's strictly greater than or less than. So if I'm thinking about the number of hours of exercise being 1 and 4, and I'm strictly in between those values, what number of hours am I talking about? That's it. 2 and 3. Between means it's not 1, it's not 4. It's between them. Okay? So I'm looking for the probability of 2 or 3 hours. Those are mutually exclusive. You'll notice that they all are, because they're individually different hours, right? So I'm going to do the probability of 2 hours, and I'm going to add to that the probability of 3 hours. And what I end up getting, I could look right up here to that C part. There's a P of 2. It was 0.136 plus P of 3. I haven't written that down yet, but if I recall my DPD, it should be 0.273. I got 7.3. And I could do it again, because if I'm talking about P of 3, that's 48, right? There was 48 players that practiced for 3 hours, and if I divide that by the total number of players, which is 176, I get 0.27272. It told me around 3 decimal places. So that second 7 rounds that second 2 to a 3. And then what I end up getting for my answer for the probability of randomly selecting a player who practiced between 1 and 4 hours is 0.409. Which reminded me I needed to clean my bathroom. I don't know why. 409. It's like cleaner. I'm like, oh, that's so random. Okay, I got 2 more for this problem, y'all. And then we're going to do the mean and the variance and the standard deviation. Okay. Can y'all see me? What about at most 3? So if I say at most, the most amount of hours that they practiced was 3, I would not be including 4, 5, or 6, right? Because that exceeds. This is more than, and it wants only at most 3 hours. So I want the probability of 1 or 2 or 3. Oh, sorry. I thought I was missing something, but I didn't know what it was because I didn't look down. Yes, I do. I want all of them. I apologize. You just don't want to go greater than 3 because it said at most, which means like that's the most. Like stop there, right? Go up to that number if it says at most. So I want probability 1 or 2 or 3. Y'all, you're going to get 0.517. And then one more. I kind of just threw that up there. Oh, God. It does include 0. I broke math. Let me kind of smush it in here, and then we'll need to add it to my 0.517, which should be adding 0.051 to it? Maybe that's why now I'm listening to myself and I knew I missed it, but it didn't really seem like I missed it because in my mind earlier, I don't think I was done writing all of this. That's why I'm starting to shorten things, and that's what I mess up. So what do y'all get?
0.568.
Mm-hmm. And that's totally like just messy right there. Okay, lastly, and I did this just so in case you see greater than, a least than, at least, at most, between, y'all, inclusive means it includes. If you, I do want to say this because I didn't do an example. Say one says between 1 and 4 hours inclusive. You do 1, 2, 3, and 4. You include everything because it said inclusive. Okay, even though it said the word between. If it throws that inclusive in there, you include what they say, those boundary points. Okay, so then lastly, G, at least 4. So at most was work your way up to and stop at, right? At most 3, you stop at 3. At least you start there and you go until you can't stop anymore, right? At least 4 hours. I want the probability of the players who practiced at least 4 hours. This is not at least 4. That's not at least 4. These are lesser than. So I want to start. When it says at least, I start where it says and I go until, the highest point, which would be 6. At most, you go up to it. At least, you start at it. Okay? So at least 4, it's going to be the probability of 4 or 5 or 6. And if I did this right and didn't mess it up, I got 0.431. You want to tell me what you get, Belinda? Yeah, okay. So I guess it was just the other one that I messed up on. Okay. So that's it's a very well-rounded discrete probability distribution lesson. That actually finishes the last class, in all honesty. Now, like this class right here, we're going to do the mean, the variance, and the, standard deviation. And I'm going to ask somebody about if there is a shortcut, but looking forward, I think there will be like computational problems on the test because that has to be something. Okay. Y'all just don't hate me, okay? So, now we're going to find the mean. We know what the mean is, right? The mean is the average. So now we're going to find the mean of a discrete probability distribution. Now, whenever we have a DPD given to us, they give it to us with probabilities, right? So what we have to do is how we're going to figure out the mean of this whenever we get that, and it's just going to be given to us in a formula, and you solve the formula. We're going to do the order of operations. That's how you work formulas by yourself. Okay, so find the mean of the discrete probability distribution. Okay, and our mean is found by, okay, so you know how we had that column of our x's, and then we had the column of our p of x's, right, all the probabilities? What it wants you to do is it wants you to multiply those two columns together and then add up that product, okay? And it looks like this. It is the sum of x times p of x. Well, obviously, if we do this by hand, we're the ones that are in charge of the order of operations. And that's the main part that you have to be careful for. On a test, I would probably give you like the whole setup, and like you might just have to fill in certain things on the column. You wouldn't have to try to figure out what to do. I'll show you what I would give you. This is the sum of all of your x's times their probabilities, okay? And then here's the actual example. Okay. I just numbered it 1. I don't know how many we have. Okay, the number of squirrels in a yard in a small town. Sorry, I love squirrels. Oh man, I said it wrong, so I'm going to delete it. The number of squirrels in a yard in a small town. Squirrels. Okay. But you see, it really doesn't matter what they say there. At the end, they will actually have us interpret some results, and that's kind of where the rounding comes into play. So, you know, there is that. But so we're given squirrels, and this isn't the data we were given before, and we create the discrete probability distribution. This is a discrete probability distribution. Okay, so we have the squirrels, like the number of them that can occur, our random variable, and then it's going to be over the probability of it occurring. So this is like they've already done the work, and they've already kind of gotten to the DPD, or the discrete probability distribution. So we have the probability that there's none squirrels, not a fun yard, 1 squirrel, 2 squirrel, all the way up to 5, y'all. So I was given all this data, right? And, well, you really don't have to think about it. This is what they tell you. They've got 0.688. Sorry, it's so small. 0.688 is the probability that you randomly select a house and it has none squirrels in the yard. 0.199 that there's 1 squirrel in the yard. 0.074 for 2 squirrels. 0.019 for 3. 0.013 for 4 squirrels, and 0.006 that a yard in a small town has 5 squirrels in it, which makes sense because that's a lot of squirrels. Okay, now what we're going to do, this is everything we're given, okay? 0.688, I had to smush it. It's super smushed. I should have just done PRB and, okay. So now what we're going to do is what it said, which is find the mean. And around 3 places. Okay, whenever I look at the formula to find the mean, it is the sum of the product of my x's and their probabilities. My x's are the 0, 1, 2, 3, 4, 5, right? And then my probabilities are all of these right here. These are the corresponding probabilities to each of the x's. And what it's telling me it wants me to do is multiply them together and then add them up. The easiest way to do this is to write down all of our x's and then write down their probabilities. After that, you actually want to do the math of multiplying them together. And then after we get done with that, at the very bottom of the third column, that's when we'll add everything up. That's your mean, okay? And so my first x, 0, 1, 2, 3, 4, 5. And I think on the homework, it just wants you to have the mean. I think it might tell you to round it or something. Like it doesn't show you this. I don't know for sure. Probably should have looked. Okay, so the probability of my x's, so P of x.
This is still 4.1?
There's like 21 problems. Okay, so P of 0, when X is 0, the probability, and it's right here, 0.688. So I'm just going to write that down right here. 0.688. Right here. Multiply them together. No, because this is already the distribution. Nope, this is the DPD. So they gave me the DPD, now I'm trying to find the mean, the variance, and the standard deviation of it. Okay, so if I multiply those together, and it told me to round to 3 decimal places, you just do 0.000 is how they kind of wrote it. And then my P of X for 1 is 0.199. Multiply those together, I get 0.199. P of X for 2 squirrels in the yard was 0.074. If I multiply those together just time-wise, y'all, I'm okay. If I multiply those together, I get 0.148. 0.3 is 0.019. Should get 0.057. For 4, when you multiply them together, you should get 0.052. And then 0.030. And I'm doing this to figure out what the mean is. And the mean, right? The mean is right here. The sum of their product. Here's their product. I just multiplied them together. Now what it wants me to do is add all these up. That's the mean. You just add them all up. 0.000, 0.199 plus 0.148 plus 0.0. If you add them all up, you're going to get 0.486. Now on the homework, it's really annoying because we need this unrounded answer to move forward and do the variance and then do the standard deviation. But what it'll do is it'll tell you round your mean to like 1 decimal place, right? So it would be 0.5. But I'm not going to write that because moving forward, we need it to stay in the 0.486. So it's just really weird the way they do that. That's your mean. Can you see, Logan? Yeah. Okay. And that's just understanding the order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay. This is multiplication happening right here. This is addition. It's touching it. It looks like multiplication, but it's not. That's addition. You add last. Okay? You multiply first. And all this is saying is take your X and multiply it to your P of X. Well, here's my X. Here's my P of X. These first 2 columns were just to see the data. This was all the work that was really required. It's just multiplying them together and then adding up their products. Okay? And then that's your mean. Now they're going to give us another formula to find a variance. I need to change pages, y'all. I got some, if you need some. Okay. Okay. Now we need to find the variance. We use this different formula. Okay. Find the variance of the discrete probability distribution. The variance was that sideways looking 6 with the square on it. And this is found by, I want to explain it to you in like the order of operations, but I'm going to just kind of read it left to right. Okay, but just the way you read it isn't really necessarily the way you work it, because it's going to start with a sum and the sum comes at the end. Okay, but the variance is going to be found by taking the sum of your X values minus your mean, all squared, multiplied by all of your probabilities. Now, order of operations. What's order of operations? Parentheses, exponents, multiplication, division, addition, and subtraction, right? So when I look at this, parentheses, right here, and an exponent, right? So I need to have all my X's, I need to have my probability, I need to know that data. But the math I'm doing is this inside of the parentheses, whatever that difference is, and then square it, then multiply it to all my probabilities, and then add it up. The only thing is we're dealing with multiple pieces of data, so it's not just one little thing. It's you have to do the same step over and over and over again before you get to your answer at the end. Okay? So I know I'm going to need my x's, which is 0, 1, 2, 3, 4, 5. And then looking at what I would do next, I'm going to do the difference of each x value, subtract the mean. So that's what I write here. I'm not going to do the work yet. I'm writing everything down. Okay. Now, after I work inside of these parentheses, I need to actually apply the square. Yeah, that exponent right there, because it's parentheses, exponents. Please excuse. So I'm going to write open x minus the mean, all close. And then after I've done that, now I'm going to multiply it to my probabilities. And then after that is going to be... Okay, so here's my probabilities. I need to write it down one more time, y'all, to just kind of finish it. This is me working within the parentheses. This is me squaring it. This is me placing my probabilities where I need them to be so that I can easily multiply them. And honestly, I would give you, if a problem moves on and ask for this and then ask for the mean and then ask for the variance, like I would kind of start building and like giving you certain things, and I'd give you a lot of this, okay? I could even probably give you almost the majority of this table, and then you have to do it for only a couple of rows. I don't know yet what I'm going to do, but I'll let y'all know beforehand, okay? We know the P of X, right? And so I'm actually going to go ahead and write those. Whenever I look at all of my data, I know that the probability at 0 is 0.688. And then the probability of 1 was 0.199. And I'm doing this for a reason, because it just makes it easier for me to compute. 2 is 0.074. 3 is 0.019. 4 is 0.013. And then we have 0.006. That's what I know, right? What's blank is what I don't know. Now I'm going to put a little note here. When we do the variance, we're going to use the mean equal 0.486. Don't use the rounded one that they tell you to answer with, because you end up getting the wrong answer. And we're going to round 3 places. 0.486. What we got on the previous page for our mean, that's what we're going to use. On the homework, it'll be like round to 1. It wants 0.5. That's what it wants for the answer. Like, well, I mean, the numbers will be different. It won't be y'all's answer, but it wants 0.5. But moving forward, if you use 0.5, everything else messes up. So don't do that. Use the original one. And we're going to round 3 places. If you read these symbols right here, that says take your x and subtract your mean. What is my x in this first row? It is 0 in the first row, so I do 0 minus. My mean is 0.486. My answer is a negative 0.486. Y'all, what does it say right here? It says the x minus the mean, and then do what to it? So while you still have this in your calculator, hit the button, that's a square, and hit enter. Round it 3 decimal places. 0.236. So look at, all right, so I've filled in a certain amount of things, and I can now figure out what my variance is. And I got to go row by row by row, and you got to kind of just work everything, right? So here I look at these symbols. It tells me take my x, and this row is 0. And I'm going to subtract my mean, which is subtract 0.486. I get negative 0.486. Okay, so that goes right here. That's what I did. I did that math. It goes here. And then when I scoot over, do you agree with me, Tyler? Those are the exact same things. Do you see that right there? Stupid ass board. I swear I hate this thing, y'all. Do you see? Pretend like you took away that squared. Is that not the exact same thing as this? Oh, okay. I just wanted you to make sure that you knew that when I'm squaring it. Okay, good. So it's in my calculator right now, right, as the answer. Just hit the button above log where it says x squared. I'm going to hit enter. It squares your answer. It squares the last thing that's in there.
Okay, I normally use the arrow in type of 2.
You could do that, the caret, but that one will automatically square it. Yeah. Okay, so then it tells you to round, so round it here to 3 decimal places, which is 0.236. And then moving forward, what did I write? Okay, well, I have all these probabilities here. Let me scoot over a little bit more. Okay, it tells me to use the squared answer and multiply it to the probability. Well, here's my squared answer. Don't use what's in your calculator because that's not rounded appropriately. Like it'll end up messing you up by a number or two. Don't do that. Do 0.236, and then it says times 0.688, and and it told me round 3 decimal places. So I get 0.162. And then you do it for the second row and the third row and the fourth row. This is what I'm saying. Like I would probably make it to where our x's, we don't have 0 through 5. That's 6 freaking x's. You know what I mean? Maybe 0 through 3 or 4. And I've done so many of them, and you do the rest. But you should be able to read a graph, and you should be able to understand like how to kind of do that, right? Okay. I'm just gonna keep going. You all ready? Okay. So moving on, the next x is 1. And I know right here I'm going to subtract the mean, which was 0.486. I hit enter, I get 0.514. While this is in my calculator, hit the square button and hit enter. And then round that to 3 decimal places. I get 0.264. Now what I want to do with this 0.264 is multiply it to 0.199, and then I need to round this to 3 decimal places. I get 0.053. Y'all see, as a whole, this thing can be intimidating, right? And just even understanding what you should do first, I would probably have all this for you. Now, as far as the homework's concerned, just follow what I'm doing. If you're doing the variance, do it in this steps, like in this manner, in this process, okay? Don't do it in a different order because it can confuse you. But each individual little steps are not bad. Here's my x. Subtract 0.486, hit enter. I get 2.514. You actually should see a pattern here. You should be able to fill out the rest of that column, but you don't have to. While I have this in my calculator, I'm going to square it, because that's what it told me to do. And I'm going to round it 3 decimal places. I get 6.320. While, nope, don't do that. Don't use this and multiply it to 0.074. I did that, actually had to delete some stuff. Hell no, they're not. This should be next to 1, right?
That's a 1. Okay.
And so then 2. I skipped 2, didn't I?
Yeah,
I need lined paper when we start doing these, y'all. Okay, hold on. Here we go. Let's just like fast forwarded the video. And then ta-da! Okay, y'all got what I got? For 1, I have 0.514. And then when you square it, you get 0.264. When you multiply it to 0.199, you get 0.053. Okay. And then for 2, do you see how crooked it is? For 2, whenever I subtract the mean from 2, I get 1.54. And then whenever I square that, I get 2.292. When I multiply it to 0.074, I get 0.170.
2 minus 0.486.
2 minus 0.486 equals 1.514.
Oh, that's good. Oh, I thought it was 1 times 5.
Oh, it's like a decimal. No, yeah, it's like a decimal. Well, it doesn't help either that. I naturally slope when I write, I guess. And then 3, yeah, look at that slope, y'all. It's like almost a perfect. Logan, baby, you have to come up here. You got like smushing your face up. Okay, so then whenever I take my x and I subtract 0.486, I get 2.54. When I square this, I get 6.320. When I multiply this to my p of x, which is what this says to do, I get 0.120. And you just kind of keep doing the same thing over and over and over, right? And then for 3, I just keep that same slope. Y'all, I get 3, I'm sorry, not for 3, for 4, right? For 4, I get 3.514. When I square it, I get 12.348. And when I do the multiplication, I get 0.161. Okay, I'm looking at Blender to check my answers here. For 5, when I subtract the mean from 5, I get 4.514. When I square that, I get 20.376. And when I multiply it to that probability that existed for x being 5, what I get is 0.122. Okay, now I did all of that for y. It told me to subtract the mean from all of my x's and then square it and then multiply it to all the probabilities. And then lastly, you add all of this hot mess up. Here's all that hot mess. That's adding it up. You do 0.162 plus, 0.053 plus, 0.170 plus, like you add this whole column up. Okay, so I'm technically doing like, subtraction, multiplication, and squaring this way, and then going down. Last column I add, y'all, I get 0.788 for my variance. Yeah, that's all this right here, right there. Because you see how in the formula it tells me the sum, and it's of what this column right here is kind of labeled, Tyler? All right, it's the sum of, and every single thing here matches.
Yeah.
So the way I'm going to get the sum of this is going to be adding all of them up. So it's like you add them up going down. Add down. That sounds weird. Add them up, going down, add down. So that's your variance. Then it tells you, find the standard deviation. The standard deviation is the square root of the variance.
We're gonna have a lot of
Nope. It's one step. The standard deviation is just taking the square root of the variance. Okay, look, find the standard deviation. Can y'all see my paper right here? So this symbol, ow. Not everybody can see me, okay? So this is our mean, right? And then the sideways 6 squared, that's the variance. And then the standard deviation, that's just the sideways 6. How do I go from here to here? If it's squared and then it's no longer squared, I took the square root of it. So to figure out the standard deviation, what you do is you take the square root of your variance. So what's my variance? 0.788?
What was the last one? The bottom one? What was that?
Oh, standard deviation. Which, in my mind, is that. Standard deviation, because I'm lazy. Deviation. Standard deviation is the easiest one. In all honesty, it is the easiest one. The variance is the harder one. Once I find the variance, though, in order to go from the symbol being squared to just the symbol, take the square root of it. If I take the square root of my variance, I get my standard deviation. And if I put this variance in the square root, what I get for my answer is 0.887. Just pay attention to, because it will ask you sometimes to round your answer, but don't round your answer moving forward. Okay, then it tells you to interpret. I decided I'm just going to use this whole page to teach now. It's only a little bit left, but I'm not writing anymore. I'm just sliding my paper down. Okay, now it tells you to interpret. What does any of this even mean? Do y'all know that we started talking about squirrels, right? I love squirrels. Sorry, I get so excited. Okay, so interpret the data. Our mean, did I write it? I didn't write it. Y'all, our mean, they want it rounded whenever you interpret it. And it tells you kind of where to round things and stuff, okay? So our mean, rounded where they tell us to, is 0.5. And then our standard deviation, rounded to where they want us to, which is to the tenths, ends up being 0.9. And so, I don't know, I need to probably do y'all's homework. Someone needs to tell me. But it's going to have you answer and I guess fill in little blanks. This is saying that in the small town, these neighborhoods, these homes, have an average, or a mean, of half a squirrel in their yards. with a standard deviation of 0.9. And that's pretty much just what you write. The interpreting can totally be confusing. Everything else is just computation, where, I mean, it's
Do I
like,
need to know this when you're-
no, not for the test. You don't, but for the homework, yeah.
I gotta write that?
Yards on average have 0.5 squirrels with a standard deviation of 0.9. And then I said, my math lab has you
Where
round.
did you get 0.9 from?
I just, right here. That's why I changed it. You aren't looking at me. The standard deviation, I said, my math lab has you round. And then look how I wrote it here. My math lab has you round. It tells you. What's the mean? Tell me what the mean is. Find it on your paper.
0.431.
0.486?
0.431. Am I looking at the right one? Oh, I'm the wrong one.
0.486. Okay. On the homework, it'll be like round your mean to the 10th place.
Oh, okay.
That's what I tried to explain real quick. I was like, hey, it kind of has you round them. And then it's like, oh, so that's your mean is your average.
Okay.
So it's like on average, you have half a squirrel in your yard. And if you actually look at all of this data, right, the standard deviation is that, the next, I don't know how to explain it. Just that there's a standard deviation of 0.9. It tells you to round it. Okay, y'all, I got one more problem.
You know that?
Yep.
Actually?
Yeah.
My hand hurts.
Oh, tell me about it. I do this for a living.
You ever have like insulated on the...
I've always, everywhere. Well, my hands always look like that because I write in markers constantly all day long. And then I noticed that, oh, did I take it off? Oh, wow. I always have, what's it called? It's little pinchies all over me. And I messed up my washer one day. Okay. Hopefully the interpretation isn't too annoying. The main chunk of this homework is actually just computationally doing it by hand, and that's going to be the big part of it. And I know a lot of y'all do come to my office hours. A handful from this class, more from my other class. But we only have so much time together, even though it's a lot of time together. It's a lot of stuff that we go over. So if y'all get confused, definitely come and hang out and ask me all the questions. Like if you need to do your homework or if you get stuck on something, I can always answer and help. Okay, so there's this problem. What is this? This is the next problem, but where's the... Hold on a minute. That's so weird that I did not include it. So, 8, 9, 10. Do you know how we... Let me do this first before I start talking and mess myself up. Yeah? Okay. Well, thanks. Past Jennifer. Okay. So we were given data, we created the discrete probability distribution. We could actually figure out the probability of certain things happening with those probabilities. And then just now what happened was they give us the discrete probability distribution, and we could find the mean, or the mean, and we could find the variance, and we could find the standard deviation. The last problem, I don't have my stuff written down like I was supposed to, but the last problem, it says, I think there's two problems like it. It says, what does it say? It says use the histogram to find the mean, the variance, and the standard deviation. So this is what they gave us in the one problem, right? They give it to us in this form, which matches us creating our own distribution. It kind of, everything just, there's continuity. Everything looks the same, right? And then the last two problems, they don't look the same. It says use the histogram to give me the mean and the variance and the standard deviation, okay? But it's actually, it's not any harder. I went ahead and just kind of zoomed in real quick to show y'all. Let me do that. Doesn't it autofocus? Okay. So it tells me to use the histogram, come up with the mean and the variance and the standard deviation. So let me get a blank piece of paper. Ooh, let me do this. Okay, find the mean. And our mean is the sum of the x values times all of their probabilities, correct? Right? Okay. Does it make sense that this is the x-axis? These are my x values. These, what are those? The probabilities? They've already created the bar graph, is all it is. Okay? So all of these are our p of x's. Each and every single one of them. All of those. So here are my x values. And then at the top of the bar is their corresponding probabilities. So if I take the sum of all of the x's times their probabilities, right? This x is 1 times, that's 0.404. Then I'm going to add to that 2 times 0.248. Then I'm going to add to that 3 times 0.225. I'm going to run out of room because I wrote too big. Then I'm going to add 4 times 0.110. And then lastly, I have an x value of 5 times its probability, which is 0.013. It's so smushed. And that's actually the last time you have to look at the chart. Just multiply. Multiply the... yeah, just it. Clear, clear, clear. 1 open, 0.404, close. Open. I'm sorry, why did I say open? Plus. And then the 2, I open these parentheses and do 0.248, and then I close them. And then plus 3, open, 0.225, close. Plus 4, open, 0.110, close. Plus 5, open, 0.013. And I get 2.08. That's the mean. Okay? So this, they started with the DPD, and then they drew their own little graph, histogram. How do you say it? Histogram graph? And so you just take each x value and multiply it to the number that's at the top of the bar, and you add all those up. Okay? In my mind, it just makes sense to do it this way, because this is multiplying the x's with the probabilities and at the same time adding them. Okay? Now whenever I get done with this, what I get for my mean is 2.08. Done there. Now, how long is our class? I'm just kidding. It's literally, it'll just finish this page right here, but it's like the exact same problem we just did. I did it so that y'all would not freak out whenever it said, oh, now use this histogram? What are these things called? These bar graphs, histogram thingies, to come up with the mean and the variance and the standard deviation. But guess what? To do the variance, it's still the same thing. It's still the exact same thing as before. Okay, you want to do it? Let's do it. I know. Okay. Some lined paper. I'll try to do this, y'all. Okay, so I know I'm going to have my column of my x's. I know I'm going to do my x's and minus my mean. And then after I find that difference, I'm going to square it. And then I know that I'm going to multiply this squared answer with my probabilities. So I kind of just write my probabilities right here so I have that column so that it's just easy. It just flows to multiply them. And then the very, very last column is going to actually be them multiplied together. Then at the very end of this column is going to be where we add them, and that's my variance. Okay. Now, I have, okay, my x values. I don't start at 0 for this one, right? On here, I start at 1. It's 1, 2, 3, 4, 5. Those are my x values. 1, 2, 3, 4, 5. So 1, and do you see right here, whenever I found the mean, I multiplied the 1 by the probability, which is 0.404. So I can go ahead and put 0.404 right here. And I am trying to use this piece of paper so that I can try to keep things a little straight. And then for 2, the probability of 2, the p of x for 2, is 0.248. And I go down 3, 0.225. And I go down 4.110. And then lastly for 5, I have 0.013. And then I'm going to go and kind of cover this up right here, y'all, because all I did was just write down my x's and my probabilities. And I got that all from here, or you get it all from here, right? Okay. And then now, my mean, 2.08. Oh, y'all, add right here.
Oh, you're adding this something?
6 decimals, sorry. Round 6 places. Round 6 decimals, round 6 places, round 6 decimal places, round however you want to call it. Okay. Okay. So I'm going to clear in my calculator. I take my x, which is 1, and I subtract the mean, which is 2.08, and I hit enter. Well, I messed up my calculator. Hold on. 1 minus 2.08. I get negative 1.08. So that goes right here. Negative 1.08. And then what do I do with my calculator? Square it. So I touch the square button and I hit enter. Rounding to 6 decimal places. 1.1. I keep everything. And then I know that I need to multiply it to the probability because that's the answer that goes here. Excuse me. So I multiply that to 0.404. And this I need to make sure that I round it to 6 decimal places. So I have I got 1, 2, 3, 4, 5, 6. So it's 0.471226. And I know it sounds crazy, but not rounding it, that messes up everything. And that's what's annoying with my math lab sometimes is not rounding it correctly. Second verse, same as the first. 2 minus 2.08 equals negative 0.08. Square button, enter. Ow. 0.0064 times 0.248. 1, 2, 3, 4, 5, 6. So 0.001587. I did round it. I rounded it.
No, the last one.
I just rounded it. 1, 2, 3, 4, 5, 6. It's got a 2 in the 7th decimal place, and so 2 just kind of goes away, and the 7 stays the same. Sorry, I got confused. And then for 3 minus 2.08 equals 0.92, square button, enter. 0.8464 times 0.225. That one only has 5 numbers after the decimal. Hi, babe. That one only has 5 numbers after the decimal. If you added a 0, that's fine. Like, it's not going to change anything, but I just kind of left it like that. Okay. And then take your x, which now we're on x being 4, subtract your 2.08, and I get 1.92, square, enter, 3.6864 times 0.110. 1, 2, 3, 4, 5, 6. It's exactly 6 decimal places, so I just keep 0.405, 504. And then lastly, take your 5, subtract your mean, which is 2.08, and write down 2.92, and then square it. It is 8.5264. Multiply it to 0.013. round if needed. 1, 2, 3, 4, 5, 6. I get 0.110843. Now, that's literally me doing all of that part of the variance, right? What I need to do now is the last part of the variance, which is to sum everything. And that's addition, order of operations, that comes last. What am I summing? I'm summing all of this, which is literally right here. So now what I do is I add this up, and that gives me my variance. And so I do 0.110843. And it must have told me to round because I actually did round, and it told me to round the actual variance to the hundredths place or 2 decimal places, so 1.18. Sometimes when I'm working through the homework problem, I forget to write round. And then find your standard deviation. The way you find standard deviation is to take the square root and it tells you to round this one also to the hundredths place. So I get 1.09. And then I'm gonna, full disclosure, not even lie to y'all, the interpretation of this one is kind of annoying. It's like a select all that apply. So there's all these sentences, and you're supposed to read all of them and just kind of deduct which one has something to do with this. The ones that made sense to me that I wrote down, well, I didn't write them down. The ones that made sense to me was that we have an average of about 2. That was one of the sentences. It said there's an average of about 2. And when I look, the mean is average. It's about 2. I selected it. And then the other one said that the data deviates about 1. That's the standard deviation, and that's about 1. The other ones didn't make any sense, and they didn't match my data, so I didn't select those, and I got it right. Okay, but if those don't make sense to you, make sure y'all let me know, because they're worded kind of funny.